Welcome to video lecture. Myself, Ashwini R.K., Assistant Professor, Civil Department, Rovni College of Engineering and Technology. Today we are going to see about pressure measurement. The pressure on a fluid is measured in two different systems. In one system, it is measured above the absolute zero or complete vacuum, and it is called as the absolute pressure. In other system, the pressure is measured above the atmospheric pressure and it is called as the gauge pressure. Thus, the absolute pressure is defined as the pressure which is measured with reference to the absolute vacuum pressure. Gauge pressure is defined as the pressure which is measured with the help of pressure measuring instrument in which the atmospheric pressure is taken as data. The atmospheric pressure on the scale is marked as 0. Vacuum pressure is defined as the pressure below the atmospheric pressure. Here, the figure represents the relationship between the absolute pressure, gauge pressure, and vacuum pressure. Mathematically, the absolute pressure is equal to atmospheric pressure plus gauge pressure. Vacuum pressure is equal to atmospheric pressure minus absolute pressure. Measurement of pressure. The pressure of a fluid is measured by the following devices: manometers and mechanical gauges. Manometers. Manometers are defined as the devices used for measuring the pressure at the point in a fluid by balancing the column of fluid by the same or another column of the fluid. They are classified as simple manometers and differential manometers. Mechanical gauges. Mechanical gauges are defined as the devices used for measuring the pressure by balancing the fluid column by the spring or dead weight. The commonly used mechanical pressure gauges are diaphragm pressure gauge, Bourdon tube pressure gauge, dead weight pressure gauge, and bellows pressure gauge. Let's see about simple manometers. A simple manometer consists of a glass tube having one of its ends connected to a point where the pressure is to be measured and the other end remains open to the atmosphere. Common types of simple manometers are piezometer, U-tube manometers, and single column manometers. Piezometer. It is the simplest form of manometer used for measuring gauge pressures. One end of this manometer is connected to the point where pressure is to be measured and the other end is open to the atmosphere as shown in the figure. The rise of the liquid gives the pressure head at that point. If at a point A, the height of the liquid, say water, is h in the piezometric tube, then the pressure at P at A is given by P is equal to rho into G into H Newton per meter square. U-tube manometer. It consists of glass tube bent in U shape, one end of which is connected to a point at which the pressure is to be measured and the other end remains open to the atmosphere as shown in the figure. The tube generally contains mercury or any other liquid whose specific gravity is greater than the specific gravity of the liquid whose pressure is to be measured. For gauge pressure calculation, let B is the point at which the pressure is to be measured, whose value is small p, the datum line is AA. Let us consider small h1 be the height of the light liquid above the datum line. h2 be the height of the heavy liquid above the datum line. S1 is the specific gravity of the light liquid. Rho1 is the density of the light liquid. Rho2 is the density of the heavy liquid. As the pressure is same for the horizontal surface, hence the pressure above the horizontal datum line AA in the left column and in the right column of the U-tube manometer should be the same. Therefore, the pressure above the AA in the left column is equal to P plus rho 1 into G into H1. Similarly, the pressure above AA in the right column is equal to rho 2 into G into H2. Hence, by equating the two pressures, we get P is equal to rho 2 GH2 minus rho 1 GH1. Next, for vacuum pressure. For measuring the vacuum pressure, the levels of the heavy liquid in the manometer will be shown as shown in the figure. Then, the pressure above AA in the left column is equal to rho 2 GH2 plus rho 1 GH1 plus P. Pressure head in the right column above AA is equal to 0. Therefore, rho 2 GH2 plus rho 1 GH1 plus P is equal to 0. Therefore, P is equal to minus of rho 2 GH2 plus rho 1 GH1. Single column manometer. Single column manometer is a modified form of U-tube manometer in which a reservoir having a large cross-sectional area about 100 times as compared to the area of a tube is connected to one of the limbs, say the left limb of the manometer as shown in the figure. Due to the large cross-sectional area of the reservoir, for any variation in the pressure, the change in liquid level in the reservoir will be very small, which will be neglected, and hence the pressure is given by the height of the liquid in the other limb. The other limb may be the vertical or inclined. Thus, there are two types of single column manometers. They are vertical single column manometer and inclined single column manometer. Here, the figure shows the vertical single column manometer. Let us consider the axis be the datum line in the reservoir, and in the right limb of the manometer when it is connected to the pipe. When the manometer is connected to the pipe, due to high pressure at A, the heavy liquid in the reservoir will be pushed down and will rise in the right limb. Let us consider delta H to the fall of the heavy liquid in the reservoir, H2 be the rise of heavy liquid in the right limb, H1 be the height of the center pipe above XX, PA be the pressure at A which is to be measured, capital A as the cross-sectional area of the reservoir, small a the cross-sectional area of the right limb, S1 as the specific gravity of liquid in the pipe, and S2 as the specific gravity of heavy liquid in the reservoir and right limb. Rho 1 as the density of liquid in the pipe, rho 2 as the density of liquid in the reservoir. Fall of the heavy liquid in the reservoir will cause a rise of heavy liquid level in the right limb. Therefore, A into del H is equal to small a into H2. Therefore, del H is equal to A into H2 by capital A. Now consider the datum line YY, then the pressure in the right limb above YY is equal to rho 2 G into del H plus H2. Pressure in the left limb above YY is equal to rho 1 into G into del H plus H1 plus PA. Equating these pressures, we have del H is equal to P is equal to rho 2 GH2 minus rho 1 GH1. Differential manometers. Differential manometers are the devices used for measuring the difference of pressure between 2 points in a pipe or two different pipes. A differential manometer consists of U-tube containing a heavy liquid whose two ends are to be connected to the point whose difference of pressure is to be measured. Most commonly types of differential manometers are U-tube differential manometer and inverted U-tube differential manometer. U-tube differential manometer is a figure which is shows the differential manometer of U-tube type. Here the figure shows us, the first figure shows both the pipes are at the different levels, and the second figure shows both pipes are the same levels. At condition 1, when both the pipes are at different levels, the difference of pressure is calculated by the formula PA minus PB is equal to H into G into rho G minus rho 1 plus rho 2 GY minus rho 1 G into X. When both the pipes are at the same level, the difference in pressure is calculated using the formula PA minus PB is equal to H into G into rho G minus rho 1. Inverted U-tube differential manometers. It consists of an inverted U-tube containing a light liquid. The two ends of the tube are connected to the points whose difference of pressure is to be measured. It is used for measuring differences of low pressure. The figure shows an inverted U-tube differential manometer connected to the 2 points A and B. The pressure difference is calculated using the formula PA minus PB is equal to rho 1 into G into H1 minus rho 2 G into H2 minus rho S into G into H. Thank you.